Alright guys, welcome to this page of the notes. And what we're going to do is a few more example problems that I've got for you here where we're solving for an unknown and we have, right, parallel lines cut by a transversal. Parallel lines cut by a transversal, right? So we're going to use all that terminology, corresponding angles, interior angles, exterior angles, alternate interior angles, right? Consecutive interior angles, right? All that terminology, vocabulary to try and solve this problem. So here we go. Let's just jump right into it. In the diagrams given below, explain how to find the value of x using postulates, theorems, and algebraic reasoning. So let's just jump right into this. Here's what I've been given. We're trying to find the value of x. I've been told that this angle right here, PRQ, is x plus 40. And this angle down here, VTU, is 2x minus 22. I need to figure out how do I find the value of x. Well, check this out. Here's what I've got. I know, right, that angle PRQ. Actually, here, you know what? I got you. Let's do this. Angle PRQ, right there, that angle in red, angle PRQ, right, is congruent, is equal to the angle RTS. How do I know that, right? Do you guys know what property, what theorem I'm using? What theorem, what postulate am I using, right, to say that that angle in red is congruent to RTS? Right? Hopefully, right, what you recognize or what you remember, right, is that those are corresponding angles. This angle right here is in the top left-hand corner of that intersection. This angle right here, top left-hand corner of a different intersection. Those are corresponding angles. Okay, awesome. Now, check this out. Angle RTS is congruent to, let me do it in a different color, VRU. How? How do I know that? How do I know that RTS is congruent, is equal to angle VT, oh, let me fix that. That should be a T right there, not an R. Sorry. VTU. How do I know that? Hopefully, right, what you see, they're vertical angles, right? Those are vertical angles. So thanks to vertical angles, well, here's, right, guys, check this out. You should remember from algebra the transitive property. Right, and here's what the transitive property says, right? Transitive property says if PRQ is equal to RTS and RTS is equal to VTU, what do I know about these two angles? Transitive property says they must be congruent. So thanks to the transitive property, angle PRQ is congruent to angle VTU. Now what that means, right? I can set these guys equal to each other. I can set them equal to each other. So do a substitution. I know what this angle is. It's x plus 40. I know what this angle is. It's 2x minus 22. So I have x plus 40 is equal to 2x minus 22. Hey, let's do a little bit of algebra. I told you, in geometry, anytime I get a chance to do algebra with you, we're going to do it. So let's go ahead and do a little bit of algebra here. I think what I want to do is subtract this x to the other side. So I'm going to go minus x minus x. That's going to leave me with 40 is equal to x minus 22. Let me squeeze up over here. I am going to have, add 22 to the other side. So I'll have 40 plus 22 is equal to x. How about 62? X is equal to 62, and since they asked me to find the value of x, I'm done. I did it. Found the value of x. Now, this was kind of a long way of going about. We already talked about the idea that when you have parallel lines cut by a transversal, alternate exterior angles are going to be congruent, right? You know that those alternate exterior angles are going to be congruent, and we just proved it, right? Corresponding angles. Then I do the vertical angle theorem. The transitive property gets me exactly that. Alternate exterior angles are congruent. That allows me to set those guys equal to each other and solve a quick little algebra problem. Hey, let's do another one. Let me erase this stuff so I got some space. And let's try this one together. Here's what we've got. Erase, erase, erase. Okay. I'm going to do, again, I need to find the value of x. I've been given angle PRS, and I've been given angle WUV. W, U, and V. Okay, how are we going to go about doing this? Well, let's see here. How about we do this? Here's what I recognize, or at least what I kind of see right away off the bat is I see this. This angle right here, PRS. So angle PRS, right, is congruent to which angle? Well, it's congruent to angle RUW. How do I know that? How do I know that PRS is congruent to RUW? Well, they're corresponding angles, right? This is in the bottom left-hand corner of this intersection, and this is the bottom left-hand corner of that intersection. So we have corresponding angles. Okay, well that's not so bad. Let's keep going. What else can I say here? Well, here's what else I can say. Here's what I see. I see then that angle WUV, so WUV, and angle RUW are supplementary. Please look, they form a linear pair. They make 180 degrees. So let's go ahead and do that. Angle RUW plus angle WUV equals 180 degrees. How do I know that? The linear pair theorem. Linear pair theorem. Those two angles right there, they have to sum to 180 degrees. They form a straight line. They're supplementary angles. They form a linear pair. They have to sum to 180 degrees. Well, here we go. Right, look. RUW is equal to PRS. So we're going to do a substitution. I can plug this angle in for this guy, because they're equal. So we're going to substitute. And here's what I wind up with. I wind up with angle PRS, right? It was RUW, but RUW is equal to angle PRS. So angle PRS plus angle WUV all have to be equal to 180 degrees. And guys, here you go. What you've got is you got yourself another algebra problem. I know angle PRS. It's 9x. Plug it in. Oh, nope. I want red. There we go. 9x plus. I know angle WUV. WUV is 22x plus 25. That all has to be equal to 180 degrees. Guys, let's do a little bit of algebra. Here we go. 9x and 22x should be 31 plus 25. That's equal to 180. What we should then do is subtract 25 to the other side. So what I wind up with then, let's see, where should I go with this? Yeah, here, let me scooch a little bit. Scooching just a little bit. All right, here we go. So now what I wind up with, I'm going to subtract 25 to the other side. I'm going to wind up with 31x is equal. So I'm going to have 180 minus 25. So that should give me 180 minus 25. How about a 155? 155 degrees. Go ahead and divide both sides by 31, right? We'll divide by 31, divide by 31. And so we wind up with x is equal to 5. So what I did is I found the value of x by simply recognizing that, hey, it turns out, right, that this angle PRS and this angle WUV have to sum to 180 degrees. They form what we know as a linear pair, and that allows me to find the value of x. All right, guys, I got another one for you right here. We're going to do a real quick little proof. Let me erase that so I've got all my space available, and I'm going to go ahead and slide this guy up. There we go. Let's go ahead and do this quick little proof. Here's what I want you to do. I want you to prove the alternate interior angle theorem. You're going to do that by proving angle 3 and angle 5. Angle 3 and angle 5 are equal, right? That they're equal to each other. The alternate interior angle theorem says alternate interior angles are congruent. They're equal to each other. We want to prove that. I tell you that P and Q are parallel lines. P and Q are parallel lines. Let's go ahead and write our proof. All right, here we go. So here's what I know. I know that P is parallel to Q. How do I know that? It's given. All right, now the next thing I know is I know that angle 3 and angle 6, right? Look at this. Angle 3 and angle 6, they're consecutive interior angles. That means they're supplementary. These two angles have to sum to 180 degrees. So angle 3 and angle 6 are supplementary. Right? And the way that I know that, right, is the same side interior angle postulate. So same side interior angles. Same side interior angles. All right, now here's the next thing I know, right? If they're supplementary, well, supplementary angles sum to 180 degrees. So I know that the measure of angle 3 plus the measure of angle 6 has to be 180 degrees, right? How do I know that? That's our linear pair theorem. That's our definition of supplementary angles. So this is our definition. Oh, sorry, I gotta squeeze supplementary angles. Right? Our definition of supplementary angles. Okay, now check this out, right? So I just talked about angles 3 and angle 6. They're same side interior angles, which means they're supplementary. So that means angle 3 and angle 6 have to sum to 180 degrees. Look at this. Look at this. Angles 5 and 6. Angles 5 and 6 are also supplementary angles. So here we go. I have angle 5 and angle 6 are supplementary. Now, I don't know that angle 5 and angle 6 are supplementary because of same side interior angles. These are not same side interior angles. How do I know they're supplementary? Look, they form a linear pair. Careful, my justification here is the linear pair theorem, not same side interior angles. 3 and 6 are same side interior angles, same side interior angles. 5 and 6 just form a linear pair. So this will be linear pair. But that means that angle 5 plus angle 6 equals 180 degrees, right? Well, that's our definition of supplementary angles. Definition of supplementary angles. All right, guys, check this out. We're almost there. You're practically to the end. Look at this. Angle 3 plus angle 6 equals 180 degrees. Angle 5 plus angle 6 equals 180 degrees. These two guys sum to 180. These two guys sum to 180. Because they both equal the exact same thing, I can set these equal to each other. They're both equal to 180. That means they have to equal each other. So this is going to be the measure of angle 3 plus the measure of angle 6 is equal to the measure of angle 5 plus the measure of angle 6. That is substitution. Let me slide up just a little bit. We are almost there. You're practically done. In fact, you are done. What you're going to do, right? Please notice, if I subtract angle 6 to the other side, minus angle 6, minus angle 6, look what happens. They cancel each other out. I'm left with angle 3 is equal to angle 5, and what I've done is I have just proven alternate interior angles are congruent. Right? That's what I set out to prove. That was my goal. I wanted to prove angle 3 and angle 5 are congruent. They're the same. They're equal to each other. And that's exactly what I just did. I proved that those guys are equal to each other. Okay, again, the idea here in this section is I know a ton of vocabulary, right? You've got exterior angles, interior angles, you've got corresponding angles, you've got consecutive angles, you've got alternate interior, alternate exterior, right? There's a whole bunch of... Just go through it as many times as you need to. Remember, flashcards are a great way to sort of help you learn all of that vocabulary, all those definitions. When I say something, what is it that I'm talking about? And then those postulates and theorems, which then allow us to solve problems. Guys, go through this set of videos as many times as you need to be comfortable with it. Also, know that this isn't going away. We're going to continue to use what we've done here in later sections, so you're going to see it over and over and over, and hopefully by repeating it over and over. Repetition is how we remember things. So just by doing repetition, I know you guys will eventually get this stuff down. I know right now it probably seems like a lot, but I promise we're going to keep using it over and over, and you'll catch on. Thank you so much for joining me for this set of notes. I had a great time looking at transversals that cut parallel lines with you. Can't wait to see you next time.